Now we will discuss about the consecutive terms of a GP. As we done this case in the while discussing AP series. Now if 3, 5 or 7 consecutive terms are given, then preceding terms will be obtained dividing A by, that is the first term, by common ratio R and succeeding term are obtained by multiplying first term by common ratio R. That is, if we are talking about 3 terms, that is 3 consecutive terms of GP, then middle term is A, succeeding term is multiplied by R, and preceding term is dividing by R. So these are 3 consecutive terms. Now the 5 terms A, succeeding term are multiplied by R, A into R, AR square, and preceding term are divided by R, A by R, A over R square. And 7 terms A into R, A into R square, again multiplied by R, AR cube, and here A by R square, A by R cube. So these are the terms, that is a consecutive term of GP, that is geometric progression. And if 4 and 6 consecutive terms of a geometric progression are given, then middle term be A over R, comma A into R. Then preceding terms are obtained by dividing A by R square, R4 and so on, and succeeding terms are obtained by multiplying A into R by R square, R4, R6 and so on. Now if we are talking about 4 consecutive terms, then middle terms are a over r, comma a into r. Succeeding term will become, on multiplying by r square, it is ar cube, and preceding term becomes, by dividing by r square, a over r cube. So these are the 4 consecutive terms of geometric progression, and 6 consecutive terms, that is middle term is a over r, comma a into r. So next term we, on multiplying by r square, become ar cube, and next term become ar, that is we will multiply ar by 4, we will get ar5, or we can say multiplying ar cube by r square, we will get c. And here dividing by r square, we get a over r cube, and the next dividing by r square, a by r5, or dividing by a by r4, we get c, or dividing a by r cube by r1 by a by r cube by r square, we get a over r5. That's our wish to learn. If we increase succeeding term by multiplying r square term by term and divide preceding term by preceding term, will be obtained by dividing each term by r square, we will get the same 4 consecutive terms and 6 consecutive terms. So these were all about the consecutive terms of geometric progression. Now we will do problem based on consecutive terms of a geometric progression. Now the problem is 3 numbers are consecutive terms of a geometric progression. So we have to assume 3 consecutive terms of geometric progression. Their sum and product are 31 over 5 and 1 respectively. That is, sum is 31 over 5 and product is 1. Now we have to find the number. So first of all, we have to assume 3 consecutive terms of geometric progression. So 3 consecutive terms are a succeeding term multiplied by r, preceding term divided by r. So these are the 3 terms. So according to condition, sum is 31 over 5, that is a over r plus a into r is equal to 31 over 5, and product is 1, that is a over r into ar is equal to 1. So from here, if we see, we get a cube is equal to 1. Cube root of unity and real root is 1. So a is 1. So by using a is equal to 1, we will get the value of r from this condition. That is 1 over r plus 1, that is 1 into r is r, 31 over 5. So we get 1 over r plus r is equal to 31 over 5 minus 1. That is, we get, on taking LCM, 1 plus r square over r is equal to 31 minus 5 over 5. So we get 1 plus r square over r is equal to 26 over 5. Now we will make cross multiplication. That is, we get 5 plus 5r square is equal to 26r. That gives 5r square minus 26r plus 5 is equal to 0. That gives 5r square minus 25r minus r plus 5 is equal to 0. These are the factor. On multiplication we get plus 25r square, that is 5 into 5r square, that is fulfilled, and on adding or subtracting we get minus 26r, that is also 2. So we'll get 5r is common, r minus 5 minus 1 is common, r minus 5 is equal to 0. That is, we get 5r minus 1 into r minus 5 is equal to 0. From here we get 5r minus 1 is equal to 0 or r minus 5 is equal to 0. That gives r is equal to 1 over 5 and r is equal to 5. So, as we get r, a value of r is 1 by 5 and r is equal to 5, then if a is equal to 1 and r is equal to 1 by 5, then the numbers are that is a over r, a and ar is, it becomes 5, 1 and 1 by 5, and if a is equal to 1 and r is equal to 5, numbers are 5, 1, 1 by 5. So in both cases we get three numbers, that is 1 by 5, 1 and 5, which are the three consecutive terms of GP. Now the next problem is find the sum of sequence, that is 5, 55, 555, 555 up to n terms. Such type of question are very important. So, for examination point of view, you have to do so many questions which are based on this type. So the solution is, just concentrate on this. How can we solve it? Sn is equal to sum of n terms. So we write here n terms. Now take 5 is common. We get 1 plus 11, 111 up to n terms. Now multiply and divide by 9. So we get 9 plus 99, 999 up to n terms. This is the way to solve this question, so that we introduce 10. 9 can be written as 10 minus 1, 99 can be written as 100, that is 10 square minus 1, and this can be written as 10 cube minus 1, plus so on up to n terms. So you can see we make the series in the form of 10 raised to power. It becomes easy to solve. So series become 10 plus 10 square plus 10 cube plus so on up to n terms, and minus 1 is common, minus 1 up to n terms. So if we see, this is the GP series, as first term is A, and if we take ratio 10 square over 10, it is 10. 10 cube over 10, it is 10. So common ratio R is 10 and first term is A. So we get 5 by 9 into A into R raised to power n minus 1 over R minus 1 minus 1 into n is n. So we get 5 over 9, 10 over 9 into 10 raised to power n minus 1 minus n. That is, Sn is equal to 50 over 9 into 981 into 10 raised to power n minus 1 minus 50 over, that is not 50, that is 5 over 9. 5 over 9n, or we can write 50 over 81 into 10 raised to power n minus 50 over 81 minus 5 over 9n. So this is a sum of n series of given sequence.